Hey everyone. Unfortunately, Laura couldn't join us today. Again. Seriously, what does she even do anymore? Why not just send an AI robot instead?
Actually, David wrote an excuse for me using Claude apparently. So apparently Claude thinks I was busy trying to figure out why my perfectly normal Linux distro needs a package manager. Silly me.
Today, we're talking to the Flatcar team about their immutable Linux distribution, because apparently the solution to works on my machine is to make sure nobody can install anything on any machine ever again.
David gets to chat with three maintainers who clearly have never heard the phrase, if it ain't broke, don't fix it. Instead, they built an operating system that updates itself monthly, whether you like it or not, has no Python, oh my heart, and treats SSH access like a crime.
We discuss how Flatcar uses something called the SysX Bakery. Sadly, no pan au chocolats here. Why you need a PhD in systemd to add a kernel module, and how they've managed to make full disk encryption even more complicated than it already was.
I mean, the real highlight? David discovers you can reboot without rebooting, which broke his brain so hard he almost forgot to mention Rust. Almost.
And my brain just broken again reading that back and remembering that conversation. Also, one of the maintainers uses 20 Xterms as a window manager, which tells you everything that you need to know about the target audience for this distro and this episode.
Will David adopt Flatcar for everything? And how many times will they mention that SSHing into nodes is bad?
Enjoy this rusty episode.
P.S. Yes, they forked from CoreOS, which was already minimal. It's like they looked at a diet and said, but what if we removed more food?
All right. Thank you all so much for joining me today. We have an almost full house, so could we please take a minute just to say hello, introduce ourselves, and share anything that we wish to share?
Hey, I'm James Laquiro, better known as Chewy, around the open source community in particular. I'm a software engineer at Microsoft. In practice, that means I maintain the Flatcar Linux distribution, but in my spare time, I also maintain the Gentoo Linux distribution.
Hey, I'm Tilo. I'm an engineering manager at Microsoft. I was engineer for roughly 15 years before I became a manager. I have a background in embedded Linux, in Linux on infrastructure, Linux on clouds, and I've worked for a variety of large cloud providers. And now I have the honor to help maintaining Flatcar with my team and maintainers outside of the company.
Yeah, hello. My name is Mathieu. I work as a Flatcar maintainer since a few years now. I'm working on various topics, for example, the provisioning with Ignition. I'm sure we are going to talk about this later in this podcast. Also, on my spare time, I like doing some electrical engineering, embedded software, and stuff like that. Yeah,
Thank you
that's
so
about
much
me.
for those introductions. So let's cover the low hanging fruit first before we get into the meatier conversation. I will assume that the majority of people listening to this podcast know what Flatcar is. But for anyone that doesn't, can we just take a minute or two to cover the bases and let them know what the project is, what its mission is, and how it helps people in this space?
So I'll start, but there are multiple angles to that. So you know how you provision applications on Kubernetes? You basically have your config YAML that specifies a few customizations that you need for your app. You don't configure the whole app. You kind of expect it to be self-contained from the container image. And then you apply that YAML to your cluster, and suddenly you have an instance of your application there that you want to run. Flatcar basically does the same for virtual machines in data centers or bare metal machines in data centers. You have a configuration how you want the node to look like, have some initial services you want to run, and then you apply that to, for instance, GCP, AWS, Azure, to your TFTP data center for bare metal, and then the node is being created from that. Just as you never directly interact with pods in regular maintenance, you don't interact with Flatcar nodes on regular maintenance. It's a self-contained thing. It is self-updating. It is to some degree self-healing. You apply your config, and then the thing is being created, and it just does its job. It doesn't get in the way. That's kind of my view of things. I don't know if Truy has a different view.
To follow on from it not getting in your way, it's also very minimal, so it has a very small attack surface, good from a security standpoint. while it looks like a regular Linux distribution, you can SSH into it and so on. It just has what you need to run Docker or Kubernetes or whatever it is, and the rest we expect you to provide in your
All right.
containers.
When you go.
And yeah, maybe to conclude, I would like to bring a bit of historical perspective on this. Flatcar is not brand new. It is around since a few years now, and even more because it has some legacy with container operating system. CoreOS is around since 10 years maybe from now. So we initially forked CoreOS to become Flatcar 4 years ago. So yeah, Flatcar is not a brand new software. It's around since a few years now through its legacy.
Building on what Shui said, the operating system isn't just minimal, it's immutable. And it can't be regularly extended at runtime. Like there's no package manager. You get what you get. You get the set of binaries included with the operating system image, and that's it. You can't apt-get install anything. And that has advantages in terms of configuration drift and version drift. The updates are full operating system images as well. And that has another benefit in that it's not just that you can't fudge with the binaries because the operating system is immutable. It's also that you always get full version sets of all of the packages included in the base OS. Like you are on Flatcar version A, and you know which bash, which git, which kernel, which everything is included exactly down to the patch level. And then with the next update, you also know what's coming, and you always have a fixed version set that's running. And that's in terms of bill of materials and inventory, that's very beneficial.
All right. Awesome. There's a lot to cover there, and I can already see 4 different forks we can go down. But I want to tackle the one that I think right now is quite topical, and then we'll come back and maybe talk about the decomposition of Flatcar and the components that make it up, right? But you mentioned immutability, and this is the thing right now, especially to Linux users, right? That there's so many different distributions that are trying to do this on the desktop and on the server side for containers. Now, for anyone who understands how Linux works, everything is pretty much a file. So when you say that this is immutable, how far is this pushed? And I'm also curious about the update path, right? Is this using AB style file systems? Is it built on top of systemd system extensions? Maybe we can go into that in a bit more technical detail for all the Linux nerds out there.
Yeah, so in general, let's wind back. The first question you had was about immutability and how that works with the Linux file concept. Most of the services need some space where they can have some temporary stuff or have their configuration files, but they never ever actually touch user-supplied configuration, as they shouldn't, right? I mean, you know, having an email service running that then fudges its own config, that would be scary. So what we do is on very first provisioning, we take that YAML config that I mentioned, and then we take the defaults that are coming with the operating system and we render out the whole root partition based on these very few inputs. And that kind of compares to the Kubernetes approach of applying applications as well, because very few inputs, sane defaults, and then you basically render out the whole configuration of the container instance. And the files in etc we actually keep writable. So if you absolutely have to, you can go there and mess around with stuff. We don't expect people to do, because that would kind of violate the no config drift paradigm that we have, but you could if you absolutely had to. And that allows for other runtime management tools like Ansible to interface with Flatcar nodes, which some users use to manage their fleets. The operating system itself, all of the OS bits are in /usr. And you see that if you look at the Flatcar root file system. So anything that might contain binaries is symlinked into USR, USR bin, USR sbin. And this is how we lay out that system. And none of the service that we ship, as Shui mentioned, it's a very limited set of services that we ship, ever tries to write anything to USR, which in turn is on a separate partition. That partition is cryptographically protected against messing around with. So if it's DM Verity that we use, if you mess around with bits there, then the reads from these partitions will simply fail. And to answer your other question, how we handle changes in the operating system itself and updates, that is done via a separate partition. So we use a very basic AB partitioning scheme that has its drawbacks. You always need 2 partitions, where you could have 1, but it also has benefits because it is incredibly robust. Like it literally doesn't get any simpler than that. You just have a place to write the other stuff that doesn't interfere with your currently running operating system. You can switch atomically to the new operating system simply by means of reboot. And the big benefit here is it's not just that you don't have any intermediate state between the two versions of the operating system, you always have a pretty seamless rollback. So there's a mechanism that you can apply, a configuration that you can deploy if you have, for instance, critical services or foundational services that you absolutely need to run. Then you can hook yourself into the update process, and when you first boot into a new partition, you can detect, is everything fine? Yes, continue, declare the new operating system as stable, and then you boot into that every single next reboot. Or detect some services didn't like the update, so reboot again. Before that is declared stable, and you're back in a known good state, and you can investigate what's going on.
If possible, I would like to add something regarding the update things. So maybe it's obvious for us, but sometimes it's not for everyone, is that the update comes from an update server. So you don't have to manually update your Flatcar instance. Basically, every month there is a new Flatcar release, and automatically, by default, you can control this, of course, but by default, every month you will get this new version of Flatcar being written on the B partition and reboot. So by default, you don't have to do anything by yourself. Everything is done automatically. And of course, you can control this through initial configuration, but by default, you get this update from a public release update server. And if you want to, you can get your own version of public update server if you want to be fully air-gapped environment from the public server. So yeah, I think it was worth to mention it.
You mentioned systemd sysext. That is what we use as well. So Thilo mentioned earlier that you get what you get, but obviously that would be quite restrictive. So if Flatcar doesn't even ship with Kubernetes out of the box. So we do extend the system, not with a package manager, but using these, again, immutable disk images effectively that get merged over the top. That's how sysexts work. Again, protected by this Verity feature. And out of the box, Flatcar has Docker and Containerd, but you can actually remove these if you don't want them, if you want something else like Podman. And these, we maintain these sysexts in a thing we call the sysext bakery, where we have a whole collection of these. They're not tied to any specific Flatcar release, so you can actually mix and match different Kubernetes versions with Flatcar versions. It gives you a lot of freedom that way.
All right, again, we've covered a lot, and I've got forks coming out my ears. But what I love so far, we've given a pretty comprehensive understanding of the parts that are making up this Linux distribution, right? We know systemd is in there, there's data and Verity, system extensions to deliver Kubernetes. It's something I'm just going to leave here, but we're coming back to that 'cause that's really cool. And we have got an update server. So that raised a couple of questions on my mind, right? So it's nice as an update server and I'm pulling things. But I'm also thinking, and I think you said at the start, Thilo, when we deploy Flatcar, we can add things to it ourselves. I'm assuming we don't expect the general user to be writing and shipping their own system extensions, or maybe we do. So how does that interfere and work with the update servers that are coming every single month and the changes that I'm making? Maybe we can, just as an example, let's just assume I want to stick on like the Falco eBPF kernel module. How do I do that? How does it work on updates? I'd love to go into that deeper.
The kernel modules are an interesting topic because they, by definition, need to correspond to the actual kernel that you're running. But to take a step back, we don't wipe the whole system when we do an update. We just replace the USR partition. So whatever you put in opt or basically var or any place in root where you dump your binaries, we're good with that. We won't touch that. You can provision your own binaries and applications in a number of ways. You can just download a tarball. Like this YAML config that I mentioned, there are dedicated sections where you can like list sources for files, HTTP sources, S3 sources, whatever you feel like. And Ignition at provisioning time would just download them and then put them wherever you want them and then schmod them to whatever mode you need them. And maybe you add a systemd unit to start it. And that's fine. So you can, if you like, you can work on a tarball basis with your applications and then care about updating them with your own mechanism. I believe sysexts are the lowest common denominator of a mechanism that can ship your binaries safely, is very easy to generate and to maintain on the server or your own update server side, and offers a built-in mechanism for actually versioning and for updating. This still doesn't cover kmod question, right? For kmods, you have multiple options. You could on each Flatcar release have your own build pipeline that would ingest new releases, would produce a system extension with your kernel modules in it, and would basically make it ready for consumption on an update server, which is basically an HTTPS endpoint that systemd sysupdate can use, and then your instances could consume that. Or there's a mechanism to build kernel modules on the operating system at first boot when a new kernel is being detected. It's a little more involving than just provisioning Flatcar, obviously, but we're talking about kernel modules. Experience is kind of expected here. We did that for a long time, for instance, with NVIDIA driver support before we actually went the whole 9 yards and pre-built sysex, system-dependent sysex that are not in the bakery, but that come over our official release servers that are bound to a Flatcar release. So you would ingest them automatically when you do the operating system update, and you would have them ready when you basically start into the new operating system version. That law is an option that's not really open for people out there, lest they maintain their own update server, because these system-dependent sysex, as we call them, need to be built in lockstep with the operating system releases. So we do that before we release the new operating system versions. And they need to be provided via a reachable update server that the main update server that we distribute update information about knows about. And it's not really, depending on the size of your operation, it's not really that hard to rebuild all of that yourself. We actually pride ourselves to have all of this very much automated and documented, so everybody could build Flatcar from sources and run their own distro with their own updates if they so desire. So that would be an option too. From my personal point of view, best option would be, if that would be a desirable KMod for users out there to have, work with us on the distro repo and make it an optional system-dependent sysex. So we build it for you on every release, and we provide it for you, and then you can determine whether you want to consume that, and you would get it directly from the upstream releases.
Nice. Yeah, I felt bad when I said eBPF module for Falco because I knew that was going down a hard path, but then you answered it anyway, so now it's fine. I don't feel guilty anymore.
We cover most of our Falco support in the bakery, if I'm not mistaken. We have a Falco bakery sysex that contains all of the parts that are not strictly dependent down to the kernel version.
All right, so again, we're covering quite a lot here of what's happening with Flatcar as a kind of distribution. So, we've spoke about, or at least mentioned, that there's some sort of YAML payload that users can provide to tweak this in some degree. So, what is the story there? How do people, I'm assuming someone listens to this and goes, right, okay, I get it. I understand what Flatcar does and the value that I'm getting from it. I want to get started. What does that kind of first hour look like for them?
Well, I guess reading the getting started documentation would be a great entry point. We have a getting started documentation to show folks how to deploy Flatcar locally using QEMU virtualization. So that's pretty nice to get started with Flatcar locally. But of course, we also do have a lot of documentation to cover all the supported cloud providers. Because Flatcar is not bound to one cloud provider, we try to support many architectures and many cloud providers. So we have the main ones, and we also have some stuff like OpenStack or VMware. But yeah, we do cover the principal cloud providers. So for each of them, we have some documentation, and basically each documentation shows you how to provision the Flatcar instances on those cloud providers, how to interact with the cloud providers' metadata, for example, getting the IP, getting the name from the instance metadata service from the cloud provider. So everything here is documented. So you can easily build your foundation to build your own workload with cloud provider.
I guess some people may be familiar with cloud provider metadata APIs, right, on magic IPs or whatever, and they might really kind of correlate this to using cloud config on cloud init. Is that what Flatcar is using under the hood?
Yeah, so for Flatcar, there is a support of cloud init, but we only support a subset of cloud init configuration. So we do recommend to use Ignition to provision the instances. Ignition is initially developed by CoreOS folks. So we use it on Flatcar, but is also used on Fedora CoreOS, on MicroOS from OpenSUSE. So yeah, it's not only Flatcar specific. And it's a bit like Cloud Init in a way, except that it runs only on first boot. So if your instance is fully provisioned and it works, well, Ignition won't run for the next boots. And you can do really low-level operation because it's triggered from the init from FS. So you can basically, I don't format your root file system before deploying stuff on it. You can use Lux encryption, for example, if you want to encrypt your disk. Inject some kernel arguments if you need to tweak some systemd parameters or tweak some kernel parameters. So yeah, that's pretty interesting. And basically where you can use Cloud Init, you can use Ignition because, for example, OpenStack has a instance metadata service. VMware has a way to provide guest info variables where you can use to inject Ignition configuration. So yeah, each cloud provider has his own way to use the user data. Ignition is a JSON file, so you can easily inject it from using Terraform or the CLI using the cloud provider API.
I'm sure some people are going to ask, why don't you use Cloud Init? Everyone's familiar with. I think the main reason is it's written in Python, and Flatcar doesn't have Python out of the box, so we need to avoid that.
Yeah, Ignition has a really small dependencies and pretty small binary. So yeah, I tried to be really specific to do one thing and to just read that configuration. Cloud Init can do a lot of stuff. So as usual, it depends on your workflow in the end. But if you can cover all your needs with Ignition, then that's perfect because it's really lightweight and yeah, easily configurable.
Does it happen to be written in Go by any chance? Right, so
Yes.
it gets the cloud native tick as well, whereas Python doesn't. So, it's all right. Now, you mentioned encrypting disks, and I always think this is a fun thing to talk about because it's easy to do and hard to do at the same time. Because when you encrypt a disk, you have to be able to unlock a disk. We're talking about secret material and secure enclaves. And with Cloud Init, and I've seen this in the past, I used to work for a company called Packet, or Equinix Metal and Bare Metal, and Cloud Init was the only way you could get anything onto these boxes at boot. And people used to stuff all sorts of secret material in there, and it always used to give me the fear. So what is I want to run Flatcar, I want to do full disk encryption, I want to pass in some sort of secret material. Is the best way to do this the metadata APIs? Is there something else built into Flatcar and Ignition? Maybe we can talk about that process a little bit.
No, I'm actually glad I dabbled with encrypted disks last week, and so that experience is still fresh. Yeah, I think one thing to mention, that's one of the biggest kind of hidden differences between Ignition and Cloud Init is that the fact that it only renders the configuration once, and that's at first provisioning. With Cloud Init, if the metadata changes or if any other aspect changes, it would just re-render the config on boot, and then you would have configuration drift. With Ignition and Flatcar, what you can do is you can have your butane config, the butane YAML or the Ignition JSON config. You can have it committed to a repository. You can deploy your node from there using that config. You can deploy another node 10 years from now. It'll render the exact same config, and both nodes will be the same. Will be very equal because they use the same configuration. So that's a huge benefit. Now, encrypting disks is an Ignition feature. It has been in there for a very long time. There's basically multiple ways you can go. If you just tell Ignition to create an encrypted device, it'll just go ahead and do it for you. If you don't supply a secret, it'll make one up. So you better go to your instance and fetch your secret and store it somewhere secret, so that you have a backup to reach your disk should the instance fail eventually. But since Ignition generated that secret, it is safely stored in the instance's configuration where Lux needs it. So as long as it's not the root partition, it's basically just integrated into regular startup and you never have to interact with it. As I said, it falls back to a sane default for the things you tell it to do and then just goes ahead and does it. You will have encryption at rest. The rest, you will have your keys stored in etc Lux, where Lux needs them anyways. Just with the root partition, that's a little bit different. You can tell it the same for the root partition, and then the provisioning will actually succeed because it just generated the secret, right? But then you better get to the instance and set a passphrase, because next time it boots, it will not be able to read the Lux configuration, which is on the root partition, because the root partition is encrypted. So the boot will actually stop very early in the process and ask you for the passphrase for your root system. You can then interact, if you like, with the serial console and hammer it in. And I know disturbingly large number of workflows that actually use that, and it's fine if it works for them, then we support that. But you can also use a number of tools in a new Ignition version. I think it's a beta version that you would need to opt in your configuration. You just say use that beta version instead of the released Ignition version. And then you can use TPM and system decrypt enroll to generate your keys, store your keys safely on the instance, and then have your instance forget everything about it. Like no backups, no nothing. Everything is just stored in the TPM. You could, of course, also pull a backup of the Lux configuration beforehand, but yeah. So all of these options are there. I think the key message is you don't need to stuff your secrets into the configuration, because when they're not there, Ignition will make them up. If you like to provide your secrets via a safe source, HTTPS or S3 or anything, Ignition will just pull it at provisioning time and then use those secrets. Like no secrets in user data, please.
There's also another option, which is Clevis, and you can have a Tang server. I haven't actually done that, so maybe one of the others could say more, but yeah, that's an option too.
All right, nice. Yeah, so the Clevis Tang thing is interesting. Obviously a bit more work, but it's there. Assuming people are deploying this stuff onto any of the major cloud providers, then they do have access to other cloud provider services, one of them being like, SSM or KMS or whatever, right? So some way to handle secret material. I'm assuming the workload identity features of any of these major clouds would just work out of the box as well. So that's, I think anyone listening who is toying with this idea, definitely just go down that path. And yeah, no secret material in Cloud Edit or Ignition. That's definitely the way to go.
You know what, I was just thinking, this just got me thinking of a new idea, which is great to have on the podcast, right? Because I know that Clevis added PKCS 11 support fairly recently, which we haven't enabled yet due to space constraints, but we're dealing with that. But if we were to have that, and I'm thinking if it was running in, say, Azure, you could maybe plug it into Azure Key Vault, and the VM would have a managed identity, so it could just fetch the key straight from Azure Key Vault, and you wouldn't have to do a thing. Maybe that idea doesn't work for some reason, but I thought it was worth mentioning.
All right, I'll drop you an email in 2 weeks to see how you get on with that proof of concept, and we'll get the code linked in the description below. All right, nice. I mean, I think so far we've given a pretty good overview of the project. There's immutability, but it sounds like that is only on the user partition of the disk, so people are free to store, or I guess even run stateful workloads, right? If you're going to be deploying a Kubernetes cluster on this, it's going to have some sort of local host mounted volume. That's okay as long as you put it into somewhere that you accept and know that that is writable and you handle your own backups properly. So yeah,
in fact, the combination of in-place updates and shipping Kubernetes as a system extension, which can also be in-place updated, really work in favor of stateful workloads, because then, well, I mean, you can still keep your operating system and your Kubernetes versions up to date on these nodes without much impact, and still, use the full power of local disk.
Yeah, it's such a strong pattern. Again, because I used to work at Equinix Metal, I was always trying to get people to do things on the Metal as much as possible. And stateful workloads are really hard, especially when Equinix Metal's overarching theme was use cluster API, not realizing that you can't do in-place upgrades with cluster API. Like, you just lose the whole machine. I'm not going down that path. We're not going to rant today. But yeah, doing this on hypervised or even running Flatcar on bare metal and getting all these in-place things is such a powerful model for when you need to do things like this. And I imagine even more so with the amount of AI, ML, compute needs and GPUs that are running around right now as well. But again, I'm going to try not to say that two-letter word again as the rest of this podcast. So
it is actually a good point, though, because that's the second benefit of in-place updates, right? When you have large Kubernetes fleets, updating your fleet by deleting and recreating instances puts a massive churn on the cloud provider, on your cluster, because you're recycling a lot of instances, right? And depending on how the budgeting works, maybe even on your budget. So having the opportunity to just stage something and then, have a 20, 30-second reboot and have it activated right away, that actually removes a lot of risk from the upgrade operation and helps a lot with the churn that deleting and recreating would impose.
Yeah, definitely, for sure. All right. I know that we're already over where I said I would be, but I did say that was going to happen anyway, so we're going to keep going. Now, with regards to the Kubernetes story here, I imagine a lot of people that are looking to adopt Flatcar, Kubernetes is going to be a core part of this these days because, let's face it, everyone's now de facto running Kubernetes at some degree of scale. Now, how do they handle these upgrades? What does that look like for them? What is okay, I've got Kubernetes 128. I mean, I hope not, but I've got Kubernetes 128 and I want to get myself up to Kubernetes 132. How do they go through this process? What is that cycle like? I know it's not a Flatcar specific question, but
Tilo has Tilo has a whole demo on that.
I have
like that.
a few demos. Mathieu as well actually helped me a lot in shaping those out, and I'll hand over to him because I've been talking too much already.
Thank you.
The key answer to your question is it's really hard to do without manual intervention because what you're talking about is major version upgrades. So Kubernetes upstream doesn't really support upgrading from 129 to 130 unattended. They want you to be aware that this is happening, that you want this, so it doesn't happen involuntary. And I think there's a bar that you need to meet, some, I don't know if it's a file interaction or something like that you have to supply in order to make Kubernetes aware. Yeah, this is 1.29 config. I really like to upgrade to 130. Minor version upgrades, though, that's easy. And Mathieu knows all about it.
Yeah, for the minor versions, it's quite easy. So as Thilo mentioned, we have to remove the bounding between the OS version and the Kubernetes version. So both of them can be upgraded independently from one to the other. So let's take the case where we run systemd sysex Kubernetes on the system, and there is a new version of Kubernetes, so a new version of the sysex image available. So what's going on? There is an inner mechanism developed by systemd, which is called systemd sysupdate, that will detect that there is a new version of the sysex image available on the server. For example, the GitHub sysex bakery release server. And it will download it, and once it's done, it will raise a flag asking for a reboot. This flag will be read by, I don't know, for example, Curd to coordinate your reboot across the nodes, and the instance will reboot. So now you have your new version of Kubernetes. And it's exactly the same thing for the OS update itself. So when there is a new Flatcar update, once the update is applied on the B partition, the software that takes care of running the update will raise a flag asking for a reboot, and same, Curd will coordinate the reboot of the nodes. Something interesting to know, so we don't do that actually we do that for Flatcar, but what I'm going to say we don't do that on Flatcar is that for the sysex update, you can really increase the reboot time of the instance by just doing a soft reboot. So you keep the kernel running, you keep the modules, everything running, but you just reboot the PID1. So you just reboot the user space stuff, systemd, and in 1 second less, you have your system rebooted, and you can get your nodes being integrated again to the Kubernetes cluster. So that's
Are you just talking about doing a kexec? Is that what you're doing there?
No, it's something really specific to systemd. I don't know what's going on under the hood, but yeah, it's basically a soft reboot, so you just restart the
I've
PID1.
never heard of this before.
This is purely user space, and it's not as scary as kexec. So kexec scares me, and I have a little bit of history, and I dabbled with kernel development in my engineering career. And if you consider all the driver state and all the in-flight I/O that you have and all the DMA requests that are ongoing, it's almost impossible to ensure from a Linux kernel perspective that all the drivers and all the mechanisms and all the subsystems actually listen to you when you as a kernel say, now you freeze and you save your state because I will, execute myself and then come up fresh. So on the kernel level, this is very scary. On the user space level, you have everything well abstracted by the isolation to the user space that the kernel brings you. So what systemd just does is basically just reaps all the processes, runs all of the shutdown commands for the processes, but then doesn't reboot, but just restarts itself. And that is an interesting option. We don't support that in production yet, but it's also very interesting to look into. And I mean, lastly, if you're only talking about systemd sysex images, for the adventurous folks, you could just remerge the new image as soon as it's been deployed. There's no need to reboot. And that would basically replace all of the binaries under the hood with the new binaries. So you probably better shut down the Kubernetes services on that instance before you do that. But it's actually not that hard to craft respective system dependencies to have that being done as soon as a new Kubernetes SysX is being merged.
All right, awesome. Yeah, I mean, I'm now wanting to reboot my computer with system without rebooting, but maybe wait till we're finished recording. I'll give it another 5 minutes. But I had no idea that was a thing, and that's really cool. And you're right, it shouldn't be a key exec because we're not modifying or changing the kernel. You are completely end user space, and you're just trying to do that thing. So that's very cool. There was one of the mechanics of the Kubernetes upgrade that I don't think we got into, and I'm thinking again from the end user perspective, which is, say I've got a cluster with 100 nodes. Are these minor updates part of a maintenance schedule with Flatcar, and I don't have to worry about it? I just go away and go to sleep and come back, and my 100 nodes have went from 1281 to 1282? Or am I SSHing into machines and doing it one by one? Like, what is that? What's the operational burden of handling these updates?
You never SSH into Flatcar machines. We have this saying, like, SSHing into Flatcar machines and trying to fetch something is roughly the equivalent of kubectl execing into your pod and then fudging something there in order to make your service work. It's not a good pattern. I don't know. I mean, it depends, right? But yeah, it's not really. It doesn't give you peace of mind when you just want to go to bed. So no, this is entirely automated. In the case of, to be honest, in both cases, both for operating system updates and for Kubernetes SysX updates, there are reboot operators for Kubernetes. Matthew mentioned QD, which we rely on in the demos. There's also a reboot operator that we maintain ourselves, the Flatcar Linux update operator. And that's basically just an operator YAML you apply to your cluster. It will watch for these flag files that both the staged Kubernetes SysX as well as a staged operating system will generate. And after generating that flag file, the update logic is basically done. Now the operator takes over and then evacuates the node. It will uncordon the node when it rejoins the cluster so the pods can repopulate. But it's configurable, like how many nodes you want to have updated at the same time, and what's your tolerance level, and all of these things. And it will slowly churn through your cluster very, very safely. And at some point, all of your cluster will be updated. So you take a look at your cluster next morning and it runs the new version.
Nice.
And something I would like to add on top of this, running Kubernetes on Flatcar is really a perfect use case for Flatcar, but you can use Flatcar without using Kubernetes. And let's suppose you have a 100 instance cluster running Flatcar but not running Kubernetes. You can still have some mechanism to coordinate the reboot of the instance. It's shipped by default on Flatcar instances. It's called Locksmith. And with this, you can coordinate the number of nodes you want to keep up, the number of nodes you allow to reboot. You can even have some logic using etcd cluster or etcd instance to coordinate the reboot. So it's not really bound to Kubernetes, but you can also use this coordinate reboot manager without using Kubernetes.
All right, awesome. All right, lastly then, let's talk about the day two side of operating Flatcar at scale. We've kind of talked about a little bit so far because we've dived into updates and how we do this, right? But I'm assuming, operators, SREs, DevOps people, whatever their titles are, they're going to want some dashboards and some web interfaces and all of that things. They're going to want metrics off of the machine. Now, I imagine node level metrics is just the same as any other Linux distribution. But there are Flatcar specific stuff, like are those log files in place for system extension updates or base operating system updates? Like, how do we get this information out from each of the individual nodes into a Grafana dashboard or something else? Or maybe there's a Flatcar, ops suite. Like, what does that day two look like for people that roll this out at infrastructure?
Maybe I can start really quick. So I mentioned earlier the update server, which is called Nebraska. And this update server will expose some Prometheus metrics on the number of instances being updated, on the number of instances running a specific channel, a specific version, a specific architecture. So if you host your own public update server, you can get a view of what's going on in your whole fleet of instances by requesting metrics from the public update server. This is just what I wanted to say.
That's actually a very good point, and it is a lot easier than it sounds because that update server doesn't serve the real files, it just serves metadata. And it knows an operation mode where you can connect to an upstream update server. So what you can do is you can set it up in a way, and it's very lightweight, where it serves your fleet, and your fleet is configured to check in with your update server URL, but it receives all of its information, like new releases, all of the release channels, and all of this information from the upstream Nebraska that we provide. And you don't need to host any files yourself either, because the information which files to pull is part of the metadata, and your instances will basically just pull the files that are on the upstream origin server as well. It will give you full insight, though, on how your updates are doing, like the version spread in your fleet, and basically the operating system details like that. So this is for the update path. Like general node information, I would refer to Node.
Node exporter.
Node exporter, thank you. Prometheus subproject. So you could basically pull these information and accumulate it in a way that you're used to. I use it a lot for these kind of insights. And I mean, taking a step back, the update process for Flatcar and particularly for system extensions is so basic and so simple. It's very, very easy to extract these from the system.
All right. Awesome. Is there anything that you want to go into that we haven't covered yet that you think would be interesting for the listener?
There's one more thing you mentioned, operating at scale and day two ops. And particularly if you run larger workloads, what is interesting to know is, Chewy mentioned at the beginning that we really very small distro. We ship basically the things that you need to run containers. We don't even ship Kubernetes. That enables us to actually have a very thorough test suite. I think we have way more than 100 scenario tests, like complex tests that are like create 3 nodes, install Kubernetes, install Nginx, install a CNI, see if everything works. And comparable thing, NFS tests are in there, networking tests, all of this, what you basically would expect. Because of this very limited feature set that we support in the distro, it makes it really easy to thoroughly and fully test everything we do. So our idea is that you can do minor upgrades or major version upgrades of the operating system on these nodes, and your applications wouldn't even notice. Because it's very, very likely that we have covered the use case that you're running already in our tests. We're very fundamentalist with our tests. They run on all of the nightlies, like all of the tests run on all of the nightlies. They run on releases, even on the alpha releases. Like we do not release an alpha that hasn't been fully tested and every test was green. But since our test suite is fully automated, and since it also supports a QEMU target, which is a very lightweight virtualization software, we run those tests on every PR that goes into the operating system repository. So we know very well the changes that are coming in, what they could cause, and we see that very, very early in the process. So we're trying to make it very hard for issues to sneak in. And we have this stabilization process, right? I already mentioned the alpha channel, which you can actually fully use, because as far as we are concerned, alpha has been fully tested. There might be half-done features that are in alpha that aren't fully released yet. If you develop and you use an alpha image, it will always be fully functional. Like you can work on it, it won't explode, because we want people that want to contribute to have a solid foundation, right? Now, when something goes to beta, when a major release goes to beta, this is as stable as we can make it. We have at this point literally tested it hundreds of times. It has passed the whole test suite hundreds of times successfully. It's been through alpha, people have used it for development, and beta is a very good candidate for running on canaries in larger deployments, right? So assuming you have this big cluster and you have a few nodes that are well monitored, you just put them on beta. And what that gives you as the user is you will always see what's coming down the release pipeline, right? So your canary nodes will upgrade, they will get the beta version. And if there is any issue with fringe workloads out there, edge cases, you'll see it on your beta. You check back with us, the upstream project, and we will never propagate a new release to stable that has known issues, right? We will always fix the issue in beta and then make sure that your workloads continue to work. And that's a very nice way to hook yourself into the stabilization process and say, yeah, I have these beta nodes, so I know what's coming. And should there be anything wrong with these beta nodes, I can tell the upstream project, so my stable nodes will always be safe. And there was nothing coming to those stable nodes that will endanger my workloads.
All right. I am going to take 10 seconds to recap everything that we've covered in less than 10 seconds. But, I think the vibe that we're getting and the knowledge that you've given to everyone today is that Flatcar is a cloud native operating system that's lightweight, immutable in all the right bits to give you safety and security with automatic updates coming down the pipe to give them confidence that their production infrastructure is exactly how they need it to be. Their own applications, they layer on top, nothing changes. They should all be getting more sleep. They should all be happy. That's my 10-second overview. Are we happy with that? Right.
Sounds good.
We can definitely update the README on the getting started and use your quote.
All right. Now, before we finish, because we're a group of Linux nerds to some degree, I'm just going to ask a couple of quick fire questions. If you don't want to answer, you can just say skip. If you want to answer, please feel free. We'll go clockwise, starting with you, Chewy. So, what is your window manager on Linux?
I use KDE these days.
A window manager for me is basically a background image and 20 xterms. But for what it's worth, I'm using GNOME, but I'm not using it much because I'm mainly work on the terminal.
I'm using Sway, the i3 Wayland.
Okay. That's good. Everyone's on Wayland, at least in one tile and window manager. So that's a good roundup. All right. IDE of choice. We'll start again with you, Chewy.
VS Code, I'm afraid. I did use Emacs back in the day, but had to give it up, sorry.
Vim. I still have it on my to-do list to check out NeoVim, but for now, Vim
Just skip NeoVim,
fine.
go straight to Helix, but I won't say anymore.
And I'm using
Sorry.
NeoVim. But without all the sugar stuff. It's basically a Vim.
All right. Lastly, what AI tools, if any, are you using now?
I'm using Copilot quite regularly, not so much with code, but just to chat through ideas. I found it very useful there, and just confirming assumptions, that kind of thing. It's very useful. Yeah, saves a lot of time just scraping the web trying to find answers.
Yeah.
Same, mostly for logos and images, sometimes for strange database query languages that I don't want to dive myself into too much. And yeah, Copilot. But it's obvious, right? Because we get the subscription for free because we work.
Yeah, I'm using whether Copilot or Gemini, but just for one specific use case, it's to generate regex. Because every 6 months I just forgot about the previous regex, so yeah, I just use it for this.
I think it's safe to say that most people are bringing AI to some degree into the workflow. I must say, I am trusting it more and more now to write code, whether that be Gemini, Claude, Copilot, any of them. I use them all because I find they all have better tasks they're suited for. But I find it allows me just to focus on the things that I enjoy, which is sometimes writing code and sometimes just prototyping stupid ideas. So, each of their own. Thank you so much for taking time out of your day to sit down with me to talk about Flatcar and just to share random things. Just because we're at 53 minutes, I don't really want to keep you any longer, but if you want one more quick fire question, I'm happy to throw at you before we say goodbye. Yeah? All right. And this one, I'll give you a minute to think. One unknown, or at least lesser known Linux tool that you use that you think the audience may not be familiar with, and I'll give bonus points if it's a Rust rewrite, just because I love Rust. So feel free to take a minute.
That's a tricky one.
Does anyone have one they want to start with?
My mind's gone blank, sorry.
So good.
I think the challenge is that you just, kind of get used to your own tool set and you don't even know what's French or what's strange because you're using it every day. And then more often than I would like, actually have people giving me feedback like, wow, you use this and that tool in this and that scenario. I've never seen that. I learned something. And then, that was a French use case, but yeah.
I thought you were going to say, oh my God, you're still using that thing? Why aren't you using this?
That does happen too, yeah.
All right. If anyone has one, feel free to share. Otherwise, I'll just say that is us done for the day. I think.
Yeah, I think I found mine. So with Wayland, I got many issues with Sway to do some screen sharing. So I discovered this project a few years ago now. It's called WL Mirror, and it's just a simple way to do a mirror of your screen. So it's pretty handy when you just sharing your screen for a meeting or during a demo or stuff like that. You can easily mirror what you want to show.
I'm not familiar with that. I'm going to check that one out.
So it's WL Mirror.
I just thought of one. maybe not that obscure, but I use the guest FS tools quite a lot, like guest mount for mounting disk images or guest fish for poking about in them in a sort of shell-like interface. I find it really useful.
Yeah, I wasn't familiar with that either. So there we go. You're 2 for 2. The pressure's on now. I'm going to have to just sit here and wait for the next hour till Tilo gets one.
Actually, Mathieu reminded me of something that is a good conversation starter when you do presentations. So I often use demos at presentations, and that's basically just staring at the terminal. One of the presentations I had at Rejects basically consisted all of demos. I didn't have any slides. And for that, I love to use cool retro term. And apparently people don't know it. If you do not know it, check it out. It's awesome. Like you have CRT kind of presets and like all of the jiggling and RGB noise, and you can play with stuff. So it makes for a really great terminal for presentations.
But it makes your video recordings about 10 times bigger, probably.
True. Because you can have static noise in the screen background, and then that makes the codecs kind of go wild.
Awesome. 3 wonderful suggestions there. And that's it. Again, thank you so much for your time. I'm going to push the big red button now, and then I'll say use 3.
Thanks for joining us.
If you want to keep up with us, consider subscribing to the podcast on your favorite podcasting app, or even go to cloudnativecampus.fm.
And if you want us to talk with someone specific or cover a specific topic, reach out to us on any social media platform.
Until next time, when exploring the cloud native landscape, on 3.
On 3.
1, 2, 3. Don't forget your
Don't
compass.
forget your compass.